Most pro competition chargers on the market will allow you to calibrate the voltage. The TP820CD and the TP1430C from Thunder Power with the latest firmware version allow you to calibrate the actual incoming voltage. This is going to give you the highest accuracy charging. Now don't be nervous if you've got one that isn't calibrated. Of course, it worked just fine before. If you have an older one, if you buy a new one and it says it's recommended to calibrate, if you don't have the capability of calibrating, don't panic, you can still use a charger. You just may find that it doesn't charge to the max efficiency or highest accuracy, well within safe levels though. From the factory, they're calibrated to charge a pack effectively up to standard safe voltages. For the pro comp guys, for the guys racing, and the ones that really want to get the most out of it, you're going to want to dial in that calibration to get it down to the thousandths of a volt or a millivolt. And we can do that very easily with both the 820 and the 1430. The most critical thing when we look at calibrating though is what we use to detect our pack voltage. We're going to need a pack to do the calibration. Choose the biggest LiPo pack that you have to do the calibration because you want to cover all of the cells that you typically use. So if you're a heli pilot and you use the 820 and typically 6S, that's fine. Use a 6S pack and calibrate the 6 ports. Don't worry about the remaining 2. It won't affect the charging overall. Same thing with the 1430. This is a high power charger. It's 1,000 watts of charging. It'll handle up to a 14S pack. Not many people have a 14S battery pack. For those that do and use a 1430, then you're fine. But if you're using it for a 10S pack, for example, or a 9S pack, just pick the biggest pack you have and do the calibration with that. But what we detect our voltage with off the battery is what we're telling the charger to recognize as its incoming voltage. So what you use to detect that voltage is very critical. It needs to be extremely accurate. I have an old Fluke 77 meter here. I take it in occasionally to make sure it's still calibrated, and it's on the nose, and it's a very accurate meter. So of course I have that to work with and use as kind of a benchmark against the other meters out there, battery meters. Avoid a balancer meter. Like for example, this one is balancing and voltage. But the problem is it's constantly adjusting the high cell down to the lower cells, so it can actually modify that voltage while you're doing your calibration and come out with an inaccurate result. On top of that, these smaller ones, and it's kind of get what you pay for. These are little $20 or less, $10 in most cases, $12. Battery meters, and we won't dictate brand or anything or show that, but essentially you see these a lot on the market. These little digital ones or the ones that just have a display. They're not very accurate. In fact, the 2 I have here in my hand are inaccurate to the 1/10 of a volt. We're calibrating to the thousandths of the millivolt. We're all the way back at a 1/10 and it's off by 1 or 2 tenths of a volt. Not a good way to calibrate your charger. And don't even go through the process. If all you have to check with are these little tiny palm size cheap $10, $15 meters, don't waste your time because you may be driving the charger even more inaccurate than it is from the factory default settings. Get a good checker. One thing I have found, and I'll give them a plug here, is Futaba's BR3000. It measures, the cool thing is it measures to the thousandths or the millivolt, 1 millivolt. And with the 1430, you're going to find out that it can actually adjust and it displays down to the millivolt. On the 820, it goes to the hundredths place, but we can work through that phantom millivolt setting as well, 1 millivolt setting. This has been extremely accurate on the nose with everything my Fluke shows and everything at the electronics store. So it's an extremely accurate. The nice thing is too is it isn't a balancer. It's just a battery checker, so it's not going to draw down any high cells while you're doing your calibration. So it's really a great way to go through and do your calibrations. A little more expensive than these little cheapies, but much, much, much more accurate. So with that, let's go ahead and move to the bench and get started with our calibration on the 1430 and the 820. The first step in getting our chargers calibrated is to make sure we have a good voltage read on the inbound side from the pack. Now, typically what we're going to do is use an external voltage meter. We've got the BR3000 from Futaba here, which is nice because it goes down to the millivolt, which is 1,000ths of a volt, which is what we can adjust the TP820CD and the 1432 as well. So it's going to be the most accurate way for us to take a look at it. Now, if you don't have all the fancy battery checkers or the highly accurate BR3000, you're going to look at outside options. Now, as I had mentioned, using something like this little digital readout on this particular voltage meter. If we look at that and take a look at the results we get, you're going to find real quickly that it's not terribly accurate. Cell number 1 it shows is 4.1, 4.09, and 4.12. So if we look at that and compare it to the BR3000's readings, we're going to find out that those vary enough since we're going to the millivolt. If we look at our first cell, this low voltage meter, this lithium voltage meter, read 4.10. It's actually 4.091. That's pretty close. But if we look at the millivolt place, we're 9 millivolts away from actually going to 4.1. If we go to the second one, it read 4.09. We've got 4.082. Our third one was listed as 4.12 volts. We've got 4.109. Now that's the most accurate of all and the closest of all of them. With that kind of variation, since we're actually going to adjust the 820 and the 1430 down to the 1 millivolt setting, this doesn't suit our purposes. It's going to get you in the ballpark, but if we're actually calibrating, you want to be more accurate than that. Now you'll notice I have the BR3000 connected through a balancing board. I went ahead and soldered into the balancing board, not recommended just for this demonstration purpose. I went ahead and soldered into the back to give myself the ability to monitor the voltage in real time while I'm making adjustments on the charger. Typically what you do is work with just the stock balancing board, and this is the stock balancing board for the 820, and then this is the stock balancing board for the 1430. I want, again, added in a lead so I could connect my BR3000 to it. But normally what you're going to do is take your battery and connect that into the standard balancing board if you're using an outboard meter like this. This Fluke 77 is an older meter, but it's checked on a regular basis, so it's accurate. And that's also what I use to verify the BR3000. So we plug into the balancing board, quick and easy way to do it, and we'll just use the first connector. These JSD-XH connectors have 2.5 millimeter between each of the pins. It's a lot easier to get to than trying to feed the probes on your meter into the balancing board, or balancing connector itself. It's very small. So we're going to use this as an example. Now when you check voltages across the balancing port, you're going to start with pin 1, which is your negative. And then since this is wired in series, from the battery itself, it's negative to positive, negative to positive to negative to positive as it goes all the way through the series. This is a 6S battery. So if we look at pin 1, we'll kick our meter on. If we look at pin 1, we're going to go negative to pin 1, put our positive in the next pin. It's going to give us a reading. If we move over now, we're going to catch the next cell, 4.08. Move over again, 4.10. If you start off with the pin 1, negative on the pin 1, and start going to each of the different pins, it's going to start aggregating as it goes through that series connection inside the battery. 4.09, so cell 1 plus cell 2 comes out to 8.17. Cells 1, 2, and 3 together come out to 12.28. So as we go down through the chain, we'll find that it's going to increase the voltage all the way up to our last connection. Since this is a 6S, I can actually show you. We'll plug in the second bank. And since this is our negative, cells 1, 2, 3, 4, 5, and 6, if we catch our negative and go on cell 6, we'll get overall pack voltage since it's catching the entire series change, 24.57 volts across the entire pack in this case. So an easy way to check it with your meter is to use the XH connection on the balancing board. It does not have to be plugged in. So the first thing you want to do is write down all your voltages. So we'll go through and check each one of those. If you're doing it with a meter, we'll go through and start writing down each of the individual voltages for cells 1 through 6 in this case. And then what you're going to do when you go into the balancing or the actual calibration section, you're going to go ahead and reference those voltages when you make adjustments on each of the ports. Like I said, we have the BR3000 tapped in, which is kind of an easy way to do it since we can monitor it real time. So let's go ahead and plug our balancing board. We've already got it plugged into the charger. We've got our BR3000 ready that we're going to use. With everything disconnected, just make sure you have your main lead and your balancing board ready. Go ahead and power on the charger. What you're going to do is, and you're going to want the latest version of the firmware. You can check the firmware update clinic if you're not comfortable, you don't know how to update the firmware. You want the latest version on both the 820 and the 1430. We're going to hold down the enter button and power on the charger, and it's going to put us into the calibration mode. So we see right now it starts off channel 1. Now this is dealing with port 1 and port 2 since this is a 2-port charger. If we want to switch between them, we just hit channel 2 for port, hit the port button, and it switches between channel 1 or port 1 and port 2. And we can adjust the main pack voltage here. So now I got everything disconnected. We're going to go ahead and connect our balancing board. There's our overall pack voltage, 24.56, and we're going to go ahead and connect our main lead to the charger. And now we've got 24.70. So our main pack voltage is off, 24.700, 24.56. We're going to go ahead and use the plus and minus to adjust that. And this indicates the offset. So we're going to want to go down to 24.5. Went too fast. We've got 24.565. We'll drop it down one. 24.559. So that's within 1 millivolt to 24.55. We don't have the third place, the millivolt listed on the BR3000 for the overall pack voltage. We just run out of display. But we'll stick it at 24.559. If we go down one more, 553 and 547. So err to the safe side, shoot right down the middle and say 24.552, 553 is a safe main pack reading. Now to move into each of the cells, the individual cells, we're going to go ahead and hit the enter button, and that's going to move us into the cells. Start off at cell number 1, it's reading 4.08. On our BR3000, if we hit the cell button, it takes us to 1S, 4.090. So, and 4.091. We've got the challenge right now of only having 2 decimal places past the single volt, which will give us up to 10 millivolt accuracy from the display perspective, but the TP820CD actually has the ability to go into the single millivolt range, and we can see that if we look at, we have a 0 offset 4.08. If we start hitting plus, you'll notice that it's staying on the 4.08, and there it goes to 4.09. And then we continue up on 4.09, several steps before we actually get to 4.1, and what we found is there's 14 discrete steps between each of the single cell, 10 millivolt plates. So there's actually 4.08 and another factor behind it we can't see on the display because there's not enough characters included in the display itself. So if we've got 14 steps, it's pretty easy to calculate. We have 0.01 volts. We're going to divide that by 14 steps. That's going to give us 0.0007. So if we work that out, if place 0 is adding nothing, place 1 is adding 7/10 of a single millivolt, we just start working out the math and down the list. So now we've got from place 0, which is a solid 1 millivolt, all the way up to 14 additional steps is going to give us 0.0098. This is going to make sense in a second. So what we're going to do is start going through each of our voltages on our cells. We're at 4.09 now, we're 4.088. So if we actually want to be 4.088, that's going to come closest to 84. So that would be our our third decimal place for single millivolt would be 8 at that point if we work out 12 steps up from the second it hits 4.08. So we'll take it down to 07 as soon as it goes to 4.07 volts. There we go. So we're going to go 12 steps up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to give us, behind the scenes, 4.0884. So you see how that works? You go 12 steps up from that whole voltage. We'll move on to the next cell and show you how that works. Hit the mode button to go to the next cell, and now we're at 4.07, 4.079. So we want to be 4.079, and it looks like 13 steps up will get us to right to the 9 millivolt place, and that's where we want to be. So we're going to go down to where it stays on 4.07. There we go. Until it just hits 06. There we go. And then we're going to go 13 places up. And now, behind the scenes, we're at 4.0791. If I continued up, I now hit my 4.08, which could be the 0098 bouncing up. So I'll stay one place down from 14 steps up, and that's going to give us my 4.079, almost at 4.08 volts. So we'll continue down through the rest of the cells and do the same thing. And now we'll move into cell number 5, or cell number 6, there we go. 4.08, we've got cell number 6 shows 4.087. So we need to establish where 4.08 begins. Take it down a little ways. until we get it to switch over to 4.08. All right, so now we're just getting into 4.08, and now we want to look at 4.087. Looks like we've got 70 and 77 at number 10 and number 11 place. We're going to go with number 10, error to the safe side of the lower voltage side. That's always the best route to go since we're dealing with a single millivolt. So we're going to go 10 places up from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we're at 4.087 in the background. Now we only have 6 cells connected. You can continue through to cell number 7 and cell number 8, but it's not a problem just to leave it the way it is. You can get back to the main screen, or the main pack voltage, by going on the enter. And to switch over to port 2, all you do is hit your port button. And now we're ready to do port 2. You're going to duplicate this procedure entirely on port 2 that we just did on port 1. Once you're finished, go back out to your main screen where it shows the battery voltage on either port 1 or port 2, and then just simply turn off the charger. Disconnect your batteries, and now your 820CD has been calibrated. We'll go ahead and move over to the 1430 and show the same procedure. With the 1430 connected, the balancing board attached, and again we used our little makeshift jumper cable that we made here for the BR3000. We'll go ahead and turn the unit on, verify that we have the latest firmware version, and then go ahead and hold down the enter key, power the unit up, and it'll go into the calibration mode. So we need to connect our battery into our balancing board. So we're going to go ahead and go into the 6S configuration, which is going to power up our BR3000. And then we need to connect our main leads to our battery as well. And now we're connected. So we've got our main pack voltage going in. We'll verify where we're at on main pack voltage. We've got 24.53. This is actually registering 24.710. So we need to go ahead and adjust down to 24.53. You can go ahead and up to the 533, 534. We know at least we have accuracy up to the 10 millivolt range. So now we're 24.534 on this main screen. So we're going to go ahead and hit the enter button to get into our individual cells. Cell number 1 is reading 4.106 volts, and we've got 4.086 volts. So we're going to go ahead and since this does display down to the 1 millivolt, we don't have to worry about our table and doing our calculations. All you do is just match what you read on the screen or what you've written down prior to connecting it. So we're going to be 086. And there we go. We got 4.086, 4.086. Move on to the next cell, which is going to be mode number 2, 4.079. We're going to adjust that as well. There we go, 4.079 volts. Move on to the next cell, 4.101. There we go, 4.101 volt. Move on to the next cell, cell 4, 4.089. All right, in this case we've got to jump between 8.4 and 9.0. So that's a safe reading because it's right at the breaking point of 4.089. So it's jumping about 6 millivolts, but is rounding up to 4.089, and that's good. We'll go ahead and move on to our next cell. And we're up to cell number 6 at 4.086, matching what's on our meter and on the TP1430. If you've got a larger battery, we have some 10S and 12S packs. You can go ahead and continue on through each of your ports to be able to adjust the 1430 completely auto calibrate it. Again, only use the largest pack you have with the most number of cells in series, and adjust it to that pack, and then it'll cover everything just fine. You don't have to calibrate all ports. And then once we're done, we're just going to hit enter to go back to our main pack voltage. Verify that we've got that where it needs to be. We can go ahead and adjust that a little bit further, 24.52. We'll take that down to a mid number, 24.54. A lot of times as you sit there and there's, even though it's a tiny little bit of current that's trickled to be able to read what's going on in the battery, you'll want to go back and verify your main pack voltage and make the final adjustment there. And then when you're finished, you can just unplug or turn off the charger and everything will be saved. And now you've calibrated your TP1430C or TP820CD chargers. You should do this about once a year. It's not a bad idea to do it at the beginning and towards the end of each season, just to make sure that everything's running within 1 millivolt accuracy. If you have any questions, you can go to the Thunder Power website at thunderpowerrc.com. If you'd like more information about chargers, charging methodologies, termination methodologies, power supplies, and all that stuff, you can go to our website at 2bfly.com. I'm Kurt with Two Brothers Hobby. Thanks for watching and good luck with your calibration.